Hello friends, I welcome you in lecture number 12 on graph theory. In this lecture we are going to discuss about subgraphs. So first we understand the meaning or definition of subgraph. Suppose I have one graph, say capital G, whose vertex set is capital V and edge set is capital E, and another graph whose vertex set is denoted by capital W and edge set is denoted by capital F. Then this graph capital H is called subgraph of capital G if vertex set of W is subset of vertex set of V and edge set of W is subset of edge set of capital G. In other words, if every vertex of H is a vertex of G and every edge of a graph H is an edge of graph G, then H is called subgraph of graph G. For example, if we consider this graph with 3 vertices and 3 edges, suppose vertices are denoted by V1, V2, V3, and if I consider this graph in which I am taking 2 vertices, this is denoted by capital H, this is denoted by capital G, and this by capital H, then we can see vertex set of capital H is set having 2 vertices V1 and V3, and there is only one edge here. Suppose edges are denoted by E1, E2, E3 in G, then here we have taken edge E1. So edge set of capital H is having only one edge, and here vertex set of capital G is V1, V2, V3, and edge set of capital G is set having 3 edges E1, E2, E3. Now we can observe that edge set is having E1 and that is subset of this set. Edge set of H is a subset of edge set of G, and similarly W, every element of W is present here, therefore W is a subset of vertex set of G, therefore capital H is a subgraph of capital G. So in this way we can understand the definition of subgraph, and now we can observe that if we want to write any subgraph of G, then we can find the subgraph of G by simply deleting vertices and or edges of graph G. Here I have constructed this subgraph capital H of G by deleting these edges E3 and E2 and one vertex V2. Similarly, I can consider another subgraph also. Suppose I consider V3, V2, V1. I am taking all the vertices here V1, V2, V3, and suppose I consider 2 edges E2 and E3, and suppose I denote this by H dash. Then H dash is another subgraph of this graph G. We can see that vertex of H dash are V1, V2, V3, and they are present in G, and edges of H dash are E2 and E3, they are also present in G, therefore H dash is another subgraph of G. So we can easily write the subgraph of a given graph G, and if we consider graph G itself, then G is also a subgraph of G. And if we consider graph G, if we delete all the edges of graph G, then we obtain this graph. This is the graph obtained from graph G by deleting all the edges. Then this is nothing but null graph, and it is also a subgraph of graph G. So every graph has at least 2 subgraphs, graph itself and the null graph obtained from graph G by deleting all the edges of the graph. So those two are called trivial subgraphs of given graph G. So they can ask you to write down subgraphs or construct subgraphs from a given graph. For example, suppose we have this graph G and suppose we want to construct subgraphs, then we can see here we have all these 5 vertices. Suppose I consider 3 vertices. I am taking V1, V2 and V3 from this, and I am considering these 3 edges. I am taking this edge and this edge, and I am taking these 3 vertices. Then this is subgraph of this graph G. Similarly, I can consider another subgraph also. Here I have taken V1, V2 and V3. Suppose I consider only V4 and V5. Then I will obtain another subgraph, V4 and V5 and this edge. Suppose I denote this by H1, this by H2. Then I have 2 subgraphs H1 and H2 of capital G. And you can observe here that in these 2 subgraphs, the set of vertices are, for H1 set of vertices is V1, V2, V3, and for H2 vertex set is vertex V4 and V5. So vertex set of H1 is disjoint from the vertex set of H2, or these 2 subgraphs H1 and H2 have no vertices in common. This type of subgraphs are called vertex disjoint subgraphs. If there are no common vertices in 2 subgraphs, then they are known as vertex disjoint subgraphs, or sometimes only disjoint subgraphs. Similarly, we can construct the graphs in which there are no edges common. Here also you can see in these 2 graphs we have taken these 3 edges in H1 and we have taken only 1 edge in H2. So there are no edges common in H1 and H2. So if that happens, then 2 subgraphs are known as edge disjoint subgraphs. So depending upon vertices and edges, we have 2 types of subgraphs: vertex disjoint subgraphs and edge disjoint subgraphs. We can construct 2 another edge disjoint subgraphs also for the same graph, say G. Let me remove this. Suppose I want to construct edge disjoint subgraphs. Then suppose I consider these 2 vertices V1, V2, and suppose I consider V4 also. So I am taking these 3 edges, edge connecting V1 and V2, edge connecting V2 and V4, and I am taking edge connecting V1 and V4. And suppose I consider V4, V5 and V3. So here I am taking this edge connecting V4 and V5, V3 and V5, and V4 and V3. So here I have to write V4, V5 and V3. So in this subgraph I have taken these edges, edge connecting V1 and V2, edge connecting V2 and V4, and edge connecting V1 and V4. And in this subgraph I have taken these edges, edge connecting V3 and V4, edge connecting V4 and V5, and edge connecting V3 and V5. So we can say that in these 2 subgraphs H1 and H2, no edges are common. So these are called edge disjoint subgraphs. Edge disjoint subgraphs means no edges are common in both the subgraphs. And vertex disjoint subgraphs means there are no vertices common in both the subgraphs. We can see that in these 2 subgraphs this V4 is common. So these two are not vertex disjoint subgraphs because there is common vertex V4 in both the subgraphs, but edges are not common, therefore these two are edge disjoint subgraphs. And we will see that every vertex disjoint subgraph is always edge disjoint. If our subgraphs are vertex disjoint, then they are always edge disjoint. But reverse is not true. Edge disjoint subgraph cannot be a vertex disjoint subgraph, and this is the example that here two subgraphs are edge disjoint, but they are not vertex disjoint because they have vertex V4 in common. So remember this, if two subgraphs are vertex disjoint, then they are always edge disjoint. So I have written all these things systematically here. First I have written the definition. A subgraph of a graph G is a graph capital H where vertex set of H W is subset of vertex set of G, which is denoted by V here, and edge set of H is a subset of edge set of capital E. And the graph G itself as well as the null graph obtained from G by deleting all the edges of G is also a subgraph of G. These are trivial subgraphs. Other subgraphs of G can be obtained by deleting certain nodes or vertices and edges of graph G. And I have written these two definitions also. They can ask you to define vertex disjoint and edge disjoint subgraphs. Two subgraphs H1 and H2 of a graph G are said to be vertex disjoint if they have no vertex in common, and they are called edge disjoint if they have no edge in common. So here I have taken another example. This is graph G having 5 vertices, and you can see I have taken two subgraphs H1 and H2 of this graph G. I have taken V1 and V5 vertices and edge connecting them as H1, and here in H2 I have taken this portion V2, V3 and V4, and we can observe that here vertex set is having two vertices V1 and V5, and here we have three vertices V2, V3 and V4. So these two subgraphs have no vertex common, therefore these two are vertex disjoint subgraphs of this graph G. And as I discussed, if two subgraphs are vertex disjoint, then they are always edge disjoint, and we can see that here there are no edges common. In H1 we have taken this edge of graph G, and in H2 we have taken these three edges of graph G. So no edge is common in H1 and H2, therefore these two are edge disjoint also. Similarly, we can construct another pair of subgraphs which are disjoint. Here I have taken V1 and V5, I have taken V2, V3 and V4 for constructing H1 and H2. You can construct your own subgraphs also. For example, if you consider this part, suppose I am taking V1, V2 and V5. Suppose I want to construct vertex disjoint subgraphs, then I have to take care that no vertices are common. So if I am taking V1, V2 and V5, then here I can consider this portion, two vertices V3 and V4. So this is another pair of vertex disjoint subgraphs. Suppose I denote this by H1 and this by H2, then we can see that no vertices are common in H1 and H2, therefore these two are vertex disjoint subgraphs, and we can see there is no edge common also, so these are edge disjoint subgraphs also. Here I have taken example showing edge disjoint subgraphs. This is graph G and these are subgraphs of graph G. Graph G has V1, V2, V3 and V4, 4 vertices and 5 edges. And for edge disjoint subgraphs, I have to take care that no edges are common in H1 and H2. So for H1 I have taken these 3 edges E1, E3 and E4, and for H2 I have taken these 2 edges E2 and E5. So these two are edge disjoint subgraphs because no edges are common. And you can observe that here V2 is common in both the subgraphs, so they are not vertex disjoint. So remember that if we have vertex disjoint subgraphs, then they are always edge disjoint subgraphs, but converse is not true. That is, edge disjoint subgraphs may not be vertex disjoint. So in this way we can easily understand the concept of subgraphs. Here we have to remember that we are considering two types of subgraphs depending on the vertices and edges. And they had asked one question on these two types of subgraphs in GTU summer 2020 exam. Define vertex disjoint and edge disjoint subgraphs by drawing the relevant graphs. So first you have to write down the definitions, and you can show one example for edge disjoint subgraphs and one example for vertex disjoint subgraphs as I have explained here. So I stop here and we will continue with upcoming lectures of graph theory. Thanks for watching.